It seems like we're live. Welcome to this live stream of MinIO DirectCSI. My name is Daniel Valdivia, and I'm an engineer here at MinIO. And today I'll be giving you introduction to DirectCSI and the problem it addresses and why you should actually look into DirectCSI to be large-scale hybrid store, object store, right? Or also any other type of applications that require locally attached volumes. DirectCSI is the perfect fit for that. Okay, so let's get started. So I want to start the talk by introducing you to the problem that DirectCSI is addressing. So in the current Kubernetes implementations, applications themselves, such as, you could have MinIO or a database like Cassandra, whenever they claim storage, they do it via a PVC, right? Now, the thing with these PVCs on most Kubernetes setups is that the CSI driver will provision you some persistent volume that may be living on some other node, right? And maybe sitting on some other drive. Now, this introduces a taxation on your application, right? This networking call going over the cable is actually introducing some overhead. So if you're trying to build, high performance applications and you're paying a tax of going over the network, this is a problem. And this is true on both bare metal deployments and cloud deployments, especially in cloud deployments where, everyone's used to PVCs coming over the network, but then they don't know that, most VMs have a limited capacity of going over the network, right? So most popular models on the cloud providers, they have 10 gigabit of throughput, right? 25. And if you're spending like all that throughput to go through your block storage over the network, you're just wasting bandwidth. Now, this is the problem today, right? So this is something that you could say, okay, what about local persistent volumes? Kubernetes offers those, right? Yes. Kubernetes offers a structure called local persistent volume, where you can actually define a resource. It looks just like a persistent volume. It has affinity, but now you can actually have it affinitized to the node where you want the application to run. So now if you have some SSD on this node, you can declare a local persistent volume, and then the PVC will claim it, right? That's part of what the Kubernetes scheduler will do, right? It will actually realize that there's affinity between the storage and the PV and the PVC. Therefore, the pod must always be scheduled on this pod. Now, this addresses the problem nicely, right? It's pretty simple if you think about it, and it solves the problem that I was describing initially, going over the wire. So now everything is fast. Now, the problem with this approach is that, okay, you have to manually provision these local persistent volumes, and you have to manage them yourself. And moreover, applications usually don't look like this. Applications usually look more like this. You have multiple replicas of the same application, right? And they are going across your cluster. And we don't know how many applications you have. You may actually be running them more like this, right? So you may actually be running multiple stateful applications, all intermingled, all across different nodes. And all of these applications, they need local persistent volume attached, right? Moreover, you may be slicing the same storage device. In this slide that I have here on the screen, I'm actually slicing the same storage solid state drive over and over, right? And in reality, things happen. You may schedule things here to schedule things there. This problem may arise, right? Now you can start seeing where the problem starts arising, right? You may actually initially have put two applications on the same SSD, and then a new SSD came along, or for some other reason, you schedule them on separate SSDs, right? So now if they're inconsistent from a different node, right? Maybe one is perfectly aligned and you know where everything is. Or what happens if a drive fails and you don't know what you were actually running there? Now you have to go and investigate. Now, this is the problem, right? So, and this is where I can summarize the problem I'm trying to describe you. Managing locally attached volumes in Kubernetes, it's a problem that scales over time, right? So managing your own PVCs, as you go through increasing scale, the complexity is larger, right? So you don't want to be doing this when your cluster starts going critical volume, right? If you go above, I don't know, 32 nodes, 100 nodes, right? And you don't want to be managing 10,000 drives yourself. You want this to be just managed for you, right? So this is where DirectCSI comes in. DirectCSI is trying to address this problem by keeping the complexity constant. Doesn't matter the scale that you have, right? It should be the same. And that's the nice thing about things that are simple. They scale pretty nice. So if I could really summarize in a very simple fashion what DirectCSI is, like you could just think of DirectCSI as a dynamic local persistent provisioning driver. So it's that simple, right? So it's pretty much you're gonna give it, actually DirectCSI is gonna detect your locally attached volumes, and it's gonna slice them as the PVCs come into place, right? So there's no interaction from your side other than formatting the drives once a new node comes online. So now, just to summarize, what are the key components that I want you to focus, right? I'm about to show you something that's cloud native, right? This was built for Kubernetes. Of course, this is it's in the name, right? It's a CSI, and CSI stands for Container Storage Interface. So this is a CSI driver built for local storage. That's why it's performant, right? Nothing beats local storage, right? So no matter how fast your storage may be over the wire, that introduces latency. So you want to get rid of that. And it's pretty simple, right? And now I'm about to show you how simple that is. So now let's get into a demo, right? So that's where I want to show you how easy it is to manage DirectCSI. Okay, so let's go. So spoiler alert. So I'm going to start by doing something pretty simple, right? So I'm going to start by getting DirectCSI installed. DirectCSI comes as a crew plugin. And if you have the crew extension of kubectl, it's as simple as typing kubectl crew install DirectCSI, right? Let's see if maybe that font is not large enough. There we go. DirectCSI, you hit install. This will download the latest binary or version of DirectCSI, and you're ready to go, right? And from now on, you can simply just do kubectl DirectCSI subcommands. So pretty convenient. Now this is part of your toolset, right? So as you're managing infrastructure, you can just bring on your, along with your kubectl, you can bring your kubectl DirectCSI binary. Even this will work on air gap environments, and they're also you're good to go. So the commands that come ship with DirectCSI, it's drives. So you can see, explore all the drives across all your nodes. They help the information about the system. Install is the one that we'll be using next, right? Because we want to initialize the system. We can also uninstall and then look at the volumes. So the volumes are actually the slices that we do inside the drives. So if I actually get started, right, DirectCSI install, this will go and create its namespace, its resources. Again, everything is bundled into the binary, so there's no internet connection needed at this point. And it will just go and initialize the system. So let's wait a couple of seconds. Now I'm tempting the demo gods by actually doing a live demo on a live stream, but I just want to show you how easy it is, right? And there's nothing to be afraid of in actually managing things this way. By the way, I have a setup of 8 machines with 10 locally attached NVMe drives, which I'm actually using to do this demo, right? So now that DirectCSI has been installed, I can actually come in here and okay, let's take a look at the drives, right? I'll first go into the command to show you like some of the options, and then I'll go into the list subcommand to show you the drives that I have on my system, right? So drives, it's about, you can define multiple access tiers. And this is pretty nice if you have multiple types of storage attached, right? You may have a beautiful server with SSDs, hard disk drives, and NVMe, or right? You mix and match. You pick your own hardware here, and then you create tiers, and you decide, some tiers may be for, archival, some maybe for, regular database, and some will be for high performance applications. Up to you, right? So you can then format the drives as well, which we'll do in a moment. You can list the existing drives, and then release and unreleased drives. So let's list what I have on this system, right? So let's make that smaller. Here we go. So if you see, after I listed, it gave me a list of all the volumes or all the block devices that are attached to my nodes that are available. And I can see, on my node 2, I have 10 NVMEs, right? Actually, I have 11. There's one for the system, but I don't want to use that one. So, and it's all across the system, right? I get this nice detail of everything that's in my system. Now I can take it from here and go and format these drives, right? So that's what I'm going to do just now. I'm going to tell DirectCSI these are the drives that I want you to use. And for that, because, well, you saw I have multiple drives, I'm actually going to tell DirectCSI only format device 1 through 10, right? I don't want to format everything in the system. So I have here a nice format command, and I'll just hit enter. And I pretty much just said device 1, comma, device 2, device 3, device 4, all over the board. Now, what DirectCSI is going to do is going to start grabbing all these drives and formatting them, right? I just did a list command again, and you can see that all the drives switch from available to ready state. This means they're ready to be used, right? We can start consuming them right away, and we don't have to worry about anything else at this point. If I were to show you the volume subcommand, right? So I told you there was a volume subcommand where you can explore what's on the system. And I'll see that there's no volumes right now because I haven't started any application. So what I want to do now is actually I want to install some stateful application. In this case, what I'm going to install is the MinIO operator, and I'm going to set up an object storage instance. So I'll do it the same way I just did DirectCSI, right? I'll do the crew plugin, kubectl crew install MinIO. This was bringing my MinIO kubectl plugin. Now I have access to the kubectl MinIO subcommands. I'll initialize the setup. Now everything is ready, and I even get a nice command to get access to some user interface. So I'm going to run this on a different shell. Oh, I have something running on 9090, guys. It's probably my development environment. I'm going to kill it. Yes, let's try that again. It worked this time. Perks of live demos, right? So now I didn't wrote down the token. So I'm going to start the port forwarding right now to a user interface that we ship with the MinIO operator. And this is to simplify operations. You could pretty much manage tenants via YAML, or you could also just have the public cloud experience and set up a tenant this way. So now that I have my port forward setup, I'm just going to go to my localhost 9090, enter the JWT token that was offered to me, and then I get this nice user interface where I can actually provision tenants, right? So MinIO is an object storage that's fully compatible with Amazon S3 API, and you can build very large-scale, very high-performance clusters. That's why we built this tool to support the MinIO use case, but there's nothing stopping you from using it for any other stateful applications that require locally attached volumes. Now, here's the thing. I'm going to set up a new tenant. So let's say my new tenant is going to be called, I don't know, let's say some big data storage, right? And I'm in the US West area. So I'm going to go with US West, and I'll just call it 1. I'm going to pick a namespace. And right off the bat, I can see that I get offered a storage class. My bare metal cluster that I'm using to do this demo doesn't have storage classes other than the default, because it's bare metal, right? There's nothing provisioning drives. But after installing DirectCSI, there's a DirectCSI storage class. If I had multiple tiers, you will see multiple classes. So in this case, I'll go with the DirectCSI. And then let's do some setup. I have 8 servers. Let's do a 4-server setup, 4 drives. And if I remember correctly, how big were my drives? Like 938 gigabytes. I don't know. Let's do a 1 terabyte setup. No, let's do a 8 terabyte setup. If I do that, I'm only getting 512 gigabytes. Yeah, that's decent. All right, and then I'll throw you some RAM into this setup. 16 gigabytes per node. I'll do my highest erasure coding configuration. And I mean, this is not meant to be a MinIO demo, but the whole idea of getting this user interface is so that you can provision object storage yourself, right? So I'll just hit create. This is going to throw me some credentials, and done. Now, my stateful application is actually deployed, right? So this is a MinIO tenant, which in turn is going to deploy. So kubectl get my namespace 1, get tenant. I just deploy a MinIO tenant resource, which in turn is going to create a stateful set, right? You can see my stateful set. And now you can see this is actually creating the pods. Most of these pods are already running. So what's going on here? So now let's explore the PVC area. You can see that the PVCs are actually getting provisioned right off the bat really quickly. And this is because the DirectCSI sees the PVC and immediately starts provisioning and slicing and dicing. So what does DirectCSI see? Let's see, right? So if I go to DirectCSI, kubectl, DirectCSI, drives list, I'll see that now my drives are actually reporting some usage, right? I'm slicing half of the NVMe for my own use. I can see there's one volume now allocated, and it's actually reporting that this drive is now in use. So that's it, right? That's simple. I didn't actually have to do any jumps and hoops, right? I just installed DirectCSI, had it initialized. It just detected all the drives from the system. I said, take them, right? Not everyone, because there's some devices over there that you see I didn't want to take. I didn't want to take that NVMe that's only 476 gigabytes. And I didn't want to take that other storage device. Anyway, so now that's it. If I go back to my pods, probably they're already coming online. So kubectl, I get pods, they're all running now. So and I see other auxiliary services from the MinIO operator coming online as well. They'll also have PVCs, and they'll actually get a storage allocated because they'll reuse the same storage class. So it was that straightforward, right? So let's actually see what the UI reports, right? In some point, we're going to start seeing everything come to life. And I can start just throwing files at this and using it right away, right? This storage is ready. It's persistent. Now, this has the advantage that, everything is local. All the pods will have affinity to wherever storage is allocated. You see DirectCSI seamlessly integrates with the scheduler. I did not have to do any specialized selector, node selector, affinity, nothing, right? Just a storage class. You want to keep it extremely simple. If I show you guys the YAML that is actually used by the MinIO operator to define its storage, you will see that even though I have some pod and affinity clauses, right, because I don't want my pods, that's my only requirement to the scheduler, I don't want them together. The PVC, the volume claim template that you see here is pretty straightforward, right? It looks like the volume claim template that you will use on any stateful set. Any stateful set just has, how big do you want your PVC and what's the storage class. You may have some additional flags. We don't need any. So that's it. Now let's, one last step is, let me show you the volumes list. So this is another mechanism where you can actually start seeing who's requesting what storage and where is it living, right? So you don't have to be inspecting things down to the PV level, right? So you can just ask DirectCSI, okay, who is actually allocating this, right? Who's living on this drive? How many volumes do I have here? This information is important. So the DirectCSI CLI offers you this. All right, so let's go back to our slides. So what did I just show you? It's simply pretty much what I just did at the end of the day is I deployed a stateful application that had multiple PVCs across multiple nodes. And then these PVCs had claims for a storage class that requested local persistent volumes. And in my instances, in this case, I tried to point out the odd SSD that I didn't want to use. In my case, it was an NVMe. I didn't want to use it. But you can select, you can have DirectCSI, and you saw by default, DirectCSI actually tried to place them also on separate drives. If I had requested less capacity, they will also have landed on separate drives for the same pod. So it's extremely simple. And you can imagine how powerful this is, that you can start your infrastructure, your bare metal infrastructure or your cloud infrastructure, because it will work the same everywhere with a certain capacity. And as you bring in more nodes with additional drives, you can just ask DirectCSI format those, and then you're just expanding the local attached volumes capacity. And it simplifies operations by an order of magnitude, right? So that's really the main takeaway that I want you to take from this conversation. And let's go to the big summary, right? So hopefully there'll be some questions coming here. But as I was telling you, DirectCSI simplifies the management of locally persistent volumes. The idea is simple, right? So we don't want to make it complicated for you. We don't want to make it complicated for us, because simplicity scales. It's an idea for applications that already take care of resiliency. Now, DirectCSI is not going to do some volume management, snapshotting, yada, yada. It's not going to do that, right? In my case, MinIO already takes care of data resiliency by doing erasure coding on every object that gets stored over there. so that if an individual drive fails, it can get replaced by a new drive, and MinIO will actually heal the data that was lost. Same is the use case for Cassandra database, right? So that's those are applications that take care of the resiliency themselves. So you don't need to add, an extra layer or an extra layer of complexity by having your persistent volumes also be backed up or snapshotted or whatever. And it also costs, right? You have to invest in any fancy SAN or NAS or any other block storage solution that comes over the wire. It will come with an additional cost. So it works for the same for bare metal and cloud deployments. You don't have to worry about, is this only for bare metal? Is this only for cloud? No, I mean, you see, we install the DirectCSI driver, it gets a pod on every node, and it detects the local attached volumes, and it just makes them available, right? It's seamless integration with the scaler. You didn't have to do anything. DirectCSI will deal with it. And then ECSI for IO-intensive applications, right? This is where, not going over the wire for your applications makes a big difference, right? So now you can trust that the throughput, the overall throughput of your applications will be different. And the scale now is actually better, right? Now you're not congesting your network for storage traffic. You're only congesting the network for application traffic, which is what you actually want to do. So yeah, all right. So that's the end of my talk. I don't know if there's any questions that you guys want to have some answers for. If not, we can keep it here. For some reason, I think my slides were not showing properly. Anyway, so all right. So thank you very much for joining this live stream. My name is Daniel Valdivia. Please join us on Slack. We're a nice community over there. Or file an issue on GitHub. Right? We have some great documentation. Visit our website at min.io, or just follow us on Twitter. So that's all for today. Talk to you soon, guys.